Hi, Gaia contest in 3 parts. 1. Architecture. Production as code. Service, process, operation, connecting them.
Wow!
Scalability of the production with pool size, migrating with one command line, and finally, exporting production in mermaid graph. Settings, general settings, even with controllers, category, requirement, type, even integer. In iris, and the target. 2. We are now in the weekend. Let's speak about the workflow. Here, we have the business service. We also have the target, which is configured in the production as code. The target is the process, hook in the output. We have onPool. onPool is triggered once every second, configured once again in the production. onPool, check if the done file exists, if the error file exists. If not, we continue. We create the log file is created, and now we can send a message to the process. The business process is quite simple. It has 5 steps. First one is to prepare the download, compute, injection, and so on. First one, prepare. Next one, download 20 files in parallel, import them in parallel once again thanks to async.io. We compute the result. Once the result is computed, we export it as a CSV. That's it. The async part is quite simple. It's using async.io, which is the standard library for Python. We send in parallel to the download operation, for example. As you can see, the send parallel is an async function. It's creating async.io task, which is send request async ng function for myop. The bottom part is just to see if one task is complete and to show log output to the console, which the console is the default output of the container. What's the benefit to using async.io? It's now we can have the production sending async request synchronously to a production.
Oh my god! Wow!
And everything is done only with Python. Let's talk about operation. Yeah. Download operation, not too much to say. It's using request. We init and uninit, we init a session. Until done, we close it. Do we need to close it? I don't know. But whatever. We download each file through one message equal file download. That's it. Let's move to the next. Oh, yeah. GaiaDB operation. It's a business operation, quite a simple one. But this one has something very special. It's using iris-DB API connect. But as you can see, there is no argument, which means it's using embedded Python and using the same process as the current operation. And that is pretty neat. The cursor has been used to execute SQL statement queries, and we even use batch insert from the cursor. Yeah. Compute result. That's the main part of the challenge. What we do here, we insert in a new table all selected rows that met the requirements. That's the query being used to be inserted inside of the requirement. We check which is the best changes. Is it a RP or a BP? Calculate the BP and the RP with this function, and we select the min max. The benefit of using SQL is everything is computed inside of Iris, which means it's quite fast. 3. Bonus and conclusion. For the bonus, I would like to show off iris-persistence, which is a Python module, open source, and a community one, that helps you to define persistent classes inside of Iris. You have min, max, requirements, even the class name you would like to protect them inside of Iris. You can even create indexes and so on. There is a command line to apply your changes inside of Iris. And this one generates the persistent class. Watch out. This module doesn't write down the CNS class. Instead, it's using Persian dictionaries properties, parameters through insert to generate a CLS class. Yeah. To conclude, it was quite some fun to make this video. It took me a lot of time. Thanks for watching. If you went through the whole video, thanks a lot. And see you next time for more Python stuff. See ya.
Biadab, memang kurang ajar, tak layak duduk sini.
Can you speak English?
Fuck you!